Have you ever played Snake, the game where you have to move a snake around the map, eat food, get bigger, and avoid walls or yourself? Well, I think it's too easy, so I built it myself, but with a twist. Introducing Weird Snake, where it's exactly the same as normal Snake, except now there are enemies that appear that try to eat you, and you've got to avoid them. There's food to eat, walls to avoid, and power-ups to get rid of enemies. But before I get into how I built it, it'd be amazing if you could smash that subscribe button, and let me know in the comments exactly what you want me to build.
As with any game, the first thing we need is a map. We'll print this map out on the terminal using Visual Studio, and I'll write in C++ because I like it and it's fast, which is bueno. Pretty much, you set the dimensions, and then you print either hyphens for the top and bottom, or vertical lines for the sides. If you just do this, you get something that doesn't look quite right, so you have to put spaces everywhere else. Then you print it, wait, and clear it pretty quickly, giving the impression that it updates. So first, we'll put the player, which will represent by the letter P, in the top left corner, and an enemy, represented by the letter E, in the bottom right corner. We'll open up a thread, and I discussed multi-threading in my last video, which you should absolutely check out, which essentially runs separately on the side and waits for user input so that we can change the direction of the snake by pressing different keys. We'll move the snake with the WASD keys so that we can very easily define what happens when the snake receives these character instructions. For example, if we want to move right and receive the D key, and we're not at the right edge of the map, we'll move to the right by incrementing the X coordinates of the snake. Of course, we know that later on we have to move multiple pieces at once, but luckily this should work if we treat the snake as a vector, which basically means collection, of individual segments, each with their own direction. We also know that we want to die if we hit the wall. Therefore, later on, we will remove the condition that stops us hitting the wall and instead write a function to die. So we have the snake moving, which is great. Now, let's eat. We need to make food appear at random coordinates. In the background in the code, there's only ever one piece of food, and when we move into it, we just change its coordinates to a new random location, giving the impression that new food is created. When we land on the food, we want to increase the score, which we increment by 1, and obviously move it. However, the biggest thing we want to do is get bigger. The act of making us bigger is easy. All we do is treat the snake like a vector of segments and put another individual segment in the back of it, since we add the segment to the back of the snake. Then, when we show the snake, we'll have one more segment behind it. Obviously, this definition of behind changes depending on which way we're facing, but that's trivial to handle. What is not necessarily easy is to move this multi-segment body in the way we want it to. That is, each piece lags behind the one in front of it by one iteration. So if you have 3 pieces moving up, and the top piece moves right, we want the second and third piece to continue moving up for the iteration. Then we want the second piece to follow the first in moving right, but the third piece to move forwards. And then in the third iteration, we want the third piece to move right. I do a lot of hardware design and low-level computer engineering, and so the first thing that strikes my mind when I imagine this is the shift register, or basically just a buffer. Basically, this is a way for data to go into a storage unit for one cycle, and then this data moves from storage unit to storage unit through the system. This is basically a buffer, so I use another vector for the incoming distances for each segment, and at each iteration I insert another direction, which pushes every other direction down the line as we want it to. We want it to go from the first piece to the second piece and to the third piece and so on until it reaches the end of the snake where we remove the useless direction. This, and surprisingly, I'm not going to lie, works perfectly. So in terms of moving the snake, the only thing we have to do now is die. So if we move into the walls or into ourselves, we die. Again, very easy code. So this is basically as far as regular Snake takes us. So now we delve into the world of madness to create Weird Snake, where we must handle enemies. Whenever we eat food, we'll generate a new enemy. Since we have multiple enemies on the map at the same time, we can't just make one and change its coordinates like we did with food. Instead, we use a vector to store all enemies in play so far. Their spawn coordinates are exactly the same code as that used to randomly move food. Now each enemy will only ever be one piece, because I wrote this code on a 4-hour flight and wanted to keep it relatively simple for the most part, and I didn't want to handle multi-segment enemies, although it is possible. So let me know if you want me to add it, or even try it out yourself. The code is in my GitHub in the description. Now the enemy needs to try and eat us, so it needs to reach us. It does this by a pretty simple algorithm that finds the closest segment of the snake to an enemy, by Pythagoras, and looks at the difference between the X and Y coordinates of the snake segment compared to its own. It always moves to try and reduce the magnitude of largest difference, so if the snake segment is really close in X coordinates, but really far away in Y, the enemy is going to move vertically to reduce this gap and get much closer. This obviously has some limitations in what happens when the enemy is right next to the snake, moving in the same direction as the snake, where it will just continue moving alongside it, instead of turning in and eating it. But that's because it has no idea about what the rest of the snake is doing. It does work quite well for the most part though, so I'm happy enough with it. Letting the enemy situation sprawl out of control makes the game too difficult, so we need to have some way of reducing the number of enemies if we want to make it playable. We do this by adding a power-up, represented by a question mark. But why this representation? Because I planned on making the power-up a surprise, where it could be one of several things, pretty much inspired just by Call of Duty, so a nuke to kill all enemies, double points, increased speed, etc. Instead, there's just one. Using the power-up removes one random enemy from the map. However, this makes it a bit too easy, so now enemies spawn at a fixed interval as well. Now, it was also a bit too difficult to make it so that any snake to enemy contact would kill you. Instead, I had a pretty good idea. An enemy can only kill you by hitting the front of the snake, and if it hits any other segment, that segment and all the segments behind it will be converted into new enemies. This was a masterstroke, and now the game actually works really well. So that's Weird Snake. The code is all on GitHub. Please smash that subscribe button, destroy the like button, and let me know whatever you'd want me to make next in the comments. Until next time.